have to do 3 days worth of work. Oh, go ahead. 3 days worth of work today. Today is Wednesday, February the 17th here at Advanced Level. And it doesn't look like we have everybody here. 369. We are missing whom? Clay. And nobody sits there anymore. Who else besides just Clay? 3, there should be 11.
Well, Macy, but she's virtual.
No, that she's part of, maybe there's 4 now, that's right. Okay, maybe there should only be 10. All right. On the last time I saw you, I guess it was Friday, we did the gum percent composition. So let's get that out because we never really finished all of that. You didn't see it online? You didn't do it online? Okay, you need to get it, it's online, you need to watch there's a virtual version of it. Okay, so when you're looking at that, do I even have a copy of it myself? Turn it over to the back. And then, was your hypothesis supported? Okay? So in other words, you just guessed on what the percent was. Was it more or less than the percent of what you thought? And then put in what you got for your percent gum and the sugar and your percent and the chewing gum. Okay? So, and then obviously, why did Dennis say choose sugarless gum? And then we need to look at number 5 is what we really want to work on today. So answer those first 4 just super quickly. If you have not done already, you should have all the work on the other side done from Friday. So you should have had hypotheses written. And again, all you're doing is just writing down your data on the other ones. What did we get kind of for your percentage on bubblegum? 71.9%? Really?
59.69.
How much? 59?
67.52.
Okay. So somewhere between 60 and 70% is sugar. You don't have to list all the other stuff in there, but obviously if you know, you got the majority of it's sugar, the rest of it is basically gum. But look at the nutritional facts down at the bottom. What does it say the approximate percent should be? How many grams of sugar versus how many total grams of gum? Do the bubble gum. That's not a rhetorical question. What would the percent, if you look at the nutritional facts, what would the percent of sugar be?
8%.
About 80%, 4/5, right? 4 grams of sugar and the whole thing is 5 grams. So what does that mean since you guys are getting 60 to 70%?
4 pieces were being chewed all out.
We probably didn't get all the sugar out, even though we weighed it like 4 times. Okay, it kept going down a little bit more, a little bit more. When there was that last little bit way deep down into the gum, it just didn't all want to come out. All right, I don't have time to sit here and let you guys just kind of go on and on because we only have like 20 minutes in class today. So you guys can just finish this. I'm gonna say it's gonna be due on Friday. Okay, so it's easy, just fill in just what you got there. But let's talk about then percent. Let's apply this concept to chemistry. I have water, and I want the percent composition by mass of water. Well, what did we say percent is in general? What over what?
Portion over the whole.
The portion or the part over the whole, right? It's the part you're interested in. Again, if we want to do the number of girls in this room, we'd count up all the people, 9, and we'd say, how many girls are there? There's 4, so it's 4 divided by 9 is going to give me the percentage of girls in this room. It's always the part that you're interested over the whole. So what's the whole going to be when I'm talking about the mass of water? What can we use as the whole?
H2O.
Yeah, but I mean, the mass. How do I get the mass of the, quote, what would go in the denominator?
The whole molecule.
Okay, meaning what? Again, it's mass, so how do I get the mass of a whole molecule? Use the periodic table, right? We get the molar mass. So the molar mass of water is equal to 2 moles times 1.01 grams per mole plus 1 mole times 16.00 grams per mole. So it's going to be 2.002 grams plus 16.00 grams, 18.02 grams that's the molar mass of water. So if the whole thing weighs 18, what part of that is hydrogen? If this is hydrogen and this is the oxygen, what's the percent of hydrogen? 2.02, 18.02, and we go times 100. Okay, and that comes out to, I think, 11.1. Somebody do it for me.
$11.2.
11.2%. Now, without doing anything else, without doing this again for oxygen, since water is only made up of hydrogen, oxygen, what must be the percentage? 88.8 must the rest be there. But we could get that by saying 16 divided by 18.02 times 100 is going to equal 88.8% oxygen. That's percent hydrogen. So percent is part of the whole. The whole is always going to be the molar mass. We already know how to calculate the molar mass. Using the periodic table, we just add up the weights. You don't have to do it as detailed like this. You can just kind of add them up and get, but it's going to be the part over the whole. What's the total weight of hydrogen? Of the 18 grams, how much is due to hydrogen? How much is due to oxygen? So if we just did a little bit bigger molecule, we said C6H12O6. Okay? So, what's the first thing I have to do?
On the molar mass of each.
Not of each, well, molar mass of the whole thing. I need the whole thing first. But to do the whole thing, I get the individual pieces. So we can, I'll show you the shortcut. We just say 6 times 12.01, 12 times 1.01, 6 times 16.00. Does everybody know where those numbers are coming from? This is the atomic mass from the periodic table, times 6 times 12 times 6. So you just do this at 72.06, 12.12, 96.00. It all adds up to 180.18. So what's the percent carbon going to be?
72 divided by 106
Divided by 180.18. My percent hydrogen is going to be 12.12 divided by 180.18. And my percent oxygen is going to equal 96 divided by 180 times 100. Do believe this comes out 39.99 something, so really you can say 40.0, 39.99. 99, what's the next digit after the 9? 993, so 39.99% carbon. What do we get for percent hydrogen? Anyone? Y'all, I'll count on Caroline. 6.726.
Yes, sir.
So 73% hydrogen. Now we could add those up and subtract from 100, or just go 96 divided by 180. 53.3. And you said 2.8. And since we have 2 decimal places there, we'll go to that. That should all add up to 100% or very close. And if it's not exactly 100%, it's because we're rounding just a little bit. I think that comes out, it looks like it's going to come out. Oh no, 9 and 3 is 12. That's 20, 16, 18. No, that comes out exactly 100. Okay, so percent. Now, that's super easy. Let's talk about how we use this. Okay, you guys keep all this. You have it all written down right now. Okay, so I'm going to erase it, but we're going to need to refer to this. Because now the question is going to ask, how many grams of carbon are in 5 grams of glucose C6H12O6. Okay, what do you think we did?
Total molar mass.
Well, I mean, again, since it's glucose, what did we just say the percentage of carbon was?
39.9.
39.9. The law of definite composition says no matter how much glucose you have, it always has the same composition by mass. It's got a definite composition. So what percentage of the 5 grams is carbon? 39.99, right? So it's just, and this is where we have to go back to 3rd or 4th grade math. I don't know when you learned this, but if I say that 39.99% of carbon is, of glucose is carbon, what does of mean in that word problem? So what? Multiply. What does is mean? Equals, right? Of in a word problem always means times. So we can say 39.9% of the 5 grams of glucose is carbon. So when you multiply by a percent, what do we have to do? Divide by 100, so it's going to be 0.3999 times 5 grams. So that's really going to come out to 40% of 5 is going to be really close to 2 grams. Probably to 3 sig figs, it's 2. So of my 5 grams, 2 grams of it's going to be carbon. So if I know the percent, I can find out how many grams of each thing there are. Now, if I was just to do this as a whole problem, then it's going to be, the way that we found this was taking the, 72.06 grams of carbon divided by 180.12 grams of glucose times the 5 grams of glucose. Notice what's happening to my units. Grams of glucose are going to cancel. And this is my percent composition, but there's no need to divide it out and multiply by 100 when you're just going to divide back by 100. So you just do this, divide by this, get the decimal, multiply by 5, and we have our answer. So, none of these pens are worth anything. Look at 3. It took my first one to get the distance. How many grams of sulfur are in 25 grams of sulfuric acid, H2SO4. Good. See if you can work this one out. Follow the exact same pattern. Let me just say this, since the question is only asking about sulfur, do we have to find the percent composition of each element?
Yes. Well, don't you have to use it for the bottom?
We have to use it for the bottom part, but we don't have to do it like we did on the last one 3 times.
Oh, yeah.
You only have to do it for the sulfur. When you're having fun. You've got a minute left. Molar mass H2SO4 is going to be 2 times 1.01. 1 times 32.09 plus 4 times 16.00. It all adds up to 2.02 plus 32.09 plus 64, 98.11. Is that what you guys got?
98.09.
Oh, no, which is that 07? This 07? Yeah, I can never remember that one, that last digit. 98.09. So what do I find, what do I do next?
32.09 divided by 98.09 times 25.
Times 25. And that all turns out to equal 8.17 grams of sulfur in my 25 grams of H2SO4. Okay? So percent composition is part over the whole. The whole is always going to be the molar mass. So if I know the formula, I know the percent. The law of definite composition. Okay? Now, again, your naming project is due on Friday. If the ion name is not on this chart or the sheet that I gave to you, you can't use it. Now, I say that, turn it up here. We know sulfate's on the chart. Therefore, we can name selenate and tellurate. We know carbon is on the chart, so carbonate. So therefore, silicate, I can name. So those are going to be okay, because they're going to follow the periodic trend. But when you start getting into sorbate or benzoic something, those aren't common ions on here. Okay, so the ion names have to be on here. So don't wait until Thursday night to do this. You're going to have problems.